ENME 351, Lab 8, King Ralph. The comparator circuit compares the voltage at V plus and V minus. The difference between the inverting and non-inverting inputs are amplified by the gain in the op amp, and when the difference is large enough, the output is moved to a high state. We see this when the LED turns on after increasing V plus with the potentiometer. For an op amp, we know that V minus and V plus are equal, and there is no current going into the op amp. Since we know V minus is equal to V in, we can use the voltage divider equation to solve for V out. After we rearrange the equation, we see that the gain is equal to 1 plus R2 over R1. For the unity gain amplifier, we know V plus must equal V minus. This leads us to see that V in equals V out. So for this amplifier, there is a gain of 1. Here is the unity gain amplifier in action. For the inverting amplifier, we use Kirchhoff's current law to find the equation, and we see that it is negative R2 over R1 times V in equals V out. The gain for this is negative R2 over R1, and we can adjust the resistance to have a gain of negative 10. The voltage divider in our circuit essentially adds an offset of 2.5 volts, so we can see the inversion of the voltage. Here's the inverting amplifier in action. For the integrating amplifier, we start knowing that V plus and V minus are equal, and there is no current going into the op amp. The impedance of a capacitor is 1 over J omega C. We can then use Kirchhoff's current law, and we find V out in the frequency domain. When we transfer this over to the time domain, we find the correct equation. Here we see the integrating amplifier in action.